Hi everybody. Let's go through AP review number 15. AP review 15 for today. In recent years, College Board has been changing the way it asks area and volume questions. Some of them are the way we have experienced them in class, but some of them are starting to change, and I thought we should take another look at area and volume, and especially note these changes that have occurred. Okay, problem number one. That one looks pretty straightforward. We're told that f is this polynomial function, and then there's this linear equation with a negative slope called y that is tangent to f, and region R is bounded by f on the x-axis, and the region F is bounded by F, L, and the x-axis. Okay. Show that L is tangent to the graph at x equals 3. Show that L is tangent to the graph of F at x equals 3. Okay, so at x equals 3, both of them should have the same slope and y value. So I'm going to find L of 3, and that's going to be 18 minus 3 times 3, or 9. And I'm going to find f of 3, and this is with calculator, so you could just do it on your calculator. 36 minus 27 is also 9. So the functions have the same value, but what about, do we need the slopes? Show that the tangent is at the point, oh yes, they need to have the same slopes. So L prime, the slope of the linear equation, is negative 3, and that's everywhere. F prime is going to be 8x minus 3x squared, and we want F prime at positive 3. So that's going to be 24 minus 27, which is negative 3. Okay, so because these have the same slope and the same as F and L have the same slope, negative 3, and share the point 3, 9, they are tangent at that point. And you might want to say tangent to each other. Or you might want to say L is tangent to F. Okay, so that's part A. What about part B? Part B says find the area of S. Well, some people like to do this problem using top minus bottom. The problem with top minus bottom here is I've got the same top everywhere, but this is one bottom, and then this is a different bottom over here. And so we kind of have to address that consideration by separating this into two integrals. We would have the integral of 18 minus 3x minus our f, which is 4x to the third, 4x squared minus x to the third dx. And I would want to do that from this point of tangency, 9, until I got here. Well, where's he? That's an x-intercept for f of x. So if I take f of x, which is 4x squared minus x to the third, and I factor out an x squared, I get 4 minus x. So this is x equal to 4. So I'm integrating from 3 to 4. Plus the integral from 4 to, where's this intercept? This is 18 minus 3x equals 0. 18 equals 3x, or x equals So the second integral goes 4 to 6, and that's just the integral of 18 minus 3x. Okay, I used my calculator to find this, and I came up with 7.997 units squared. Don't forget to set this out. Don't just find this and write this answer down when you have a problem that uses the calculator. Okay, finally part C, we're looking for a volume of rotation. We're looking to take R, this region, we're taking R, and we're rotating it about the x-axis. Well, it makes sense to me with this problem to do it in the form of disks, where R equals Y equals 4x squared minus x to the third. And so I'm going to integrate from 0 to 4, don't forget that pi, radius x squared minus x to the third squared. Many students forget this squared, please don't. And when you do that on your calculator, you should end up with 156.038 units cubed. All right, there's problem number 1. Problem number 2 looks also pretty traditional. Let's see. 2 says, find the area of R. You know, we could do this one of two ways. We could do top minus bottom and split it into two integrals. Or we could do right minus left and use one integral. For those of you who are keen to do top minus bottom, you're going to have to find the point of intersection for ln of x and 5 minus x on your calculator. When you do, that is x equals 3.693441. So, integral from 1 to 3.693441 of the ln function, ln of x dx, plus the integral from 3.693441 out to 5, that's the x-intercept for this line, of 5 minus x dx. Okay, so that's one way to do it, but I like doing this problem as right minus left, because then I only need one integral. However, I do need to solve each equation for x equals. So right now I've got y equals ln of x. I exponentiate and get e to the y equals x. And here I have y equals 5 minus x, or x equals 5 minus y. So then, my right minus left integral would be 5 minus y minus e to the y. And remember, I'm integrating from here to here, and y value here at this point of intersection, this y value is 1.30656. So I'm integrating from 0 to 1.30656 dy, and I end up, either way I do this problem, with 2.985. Okie doke. So that's one way to do, or two different ways to do part A. What about part B? Part B says R is the base of a solid. Cross sections are perpendicular to the x-axis. Write but do not evaluate an integral expression. One or more integrals to find the volume of that solid. Well, here I am doing that top minus bottom. And I'm imagining squares here. And the side length of those squares is my y value. So I'm integrating from 0 to, we said that was 3.693441. ln of x is the side length squared. plus the integral from 3.6934414 up to 5 of 5 minus x squared dx. All right, and that's it. And oh, no, we didn't start at 0. Look at the picture. Started at 1. And a 0 doesn't exist. It's good to think about your work. Okay, go away. 1. Okay, there's B. And what about part C? Part C says the horizontal line divides R into 2 equal areas. Okay, so we found the area of R in part A. And we said that was 2.985 equals area of R. And what we want to do is we want to have half of that area, and there's a line y equals k. And so I'm thinking about this kind of a situation, y equals k. And again, you could do a top minus bottom kind of thing, but look now, you got 1, 2, 3 tops. Or you've got 1, 2 tops for the same bottom. I kind of like, in this case, instead doing right minus left. I think that's a lot easier, and saying the integral of 5 minus y minus e to the y dy from 0 to k, the integral this way should equal half of 2.985. That's probably how I would do that problem. Okay, next, problem number 3. Problem number 3 says we've got f and g are functions. F equals 2x 1 minus x. G equals 3, x minus 1, square root of x. And we're looking at the interval from 0 to 1. Okay, which function is on top? G of x is on the bottom, f of x is on the top. How convenient. Find the area of the shaded region. So that's just the integral from 0 to 1 of f minus g dx. I do that on the calculator and I get 1.133 units squared. Here's part A, pretty painless. Part B, find the volume of the solid when the shaded region is revolved around y equals 2. Okay, so we're taking this region and we're rotating it around y equals 2. I'm not going to do shells because the right and left are the same function. Instead, I'm going to do washers, where little r equals 2 minus f, and big R equals 2 minus g. And it says here that I'm supposed to find that volume. Okay, so I'm going to say I, 0 to 1, 2 minus g squared minus 2 minus f squared dx. I'm going to type these in to y1 and y2, but when I evaluate this with my calculator, I ended up with 16.179 units cubed. Okay, I don't think you need me to see me type it into the calculator, so I'm just going to go with there's the setup, and you can type it into your calculator. Okay, part C, let h equal this other function. So h is a variation on f. kx minus x. So this is going to be some sort of stretching factor. We're always going to have the bottom, except the top is going to grow larger and larger and larger. Okay, depending on our k value. So then it says here, excuse me, there is a value for which the volume of the solid cross sections are perpendicular to the x-axis. So we're going to make that, and we want the volume to be 15. So 15 equals the integral of h minus g dx from 0 to 1. Now, there's a k in here. And so when I look at this, I'll write but do not solve an integral expression that could be used to find k. This is side length, but I want side length squared. I think that's my answer. Of integrating squares perpendicular to the x-axis, k. Yes, if I integrate this function and plug in those values, h will have k's in it. I'll be able to solve this equation for k. Yes, I like that. Okay. Next, number 4. 4 says, oh, and this sort of thing where you don't write out the functions, we can do that because College Board has defined those functions for us, and so we're just using a shorter name for them. You're more than welcome to write them out if you like. Don't you go doing something like this without defining a function if you want to do something like that, and the function isn't already defined. Okay, number 4. 4 says, let R be the region bounded by the graphs y equals sine pi x, y equals x to the third minus 4x, as shown not above, but below to the right. There's R. Okay. I see my sine thing. I see a polynomial thing. And just to be clear, the sine thing is the one on top. This is my top. This is my bottom. How do I know that? Well, if I set pi x equal to 0 and pi x equal to 2 pi, I get 0 and 2 are the endpoints, and so halfway between would be pi. Would be 1. And so my sine graph 1, 0, 1, 2 goes up, down, like that. So this must be my top function, and then I've got this bottom polynomial function here. Okay, what am I doing with this? Part A, find R. Okay, so that's going to be the integral from 0 to 2 of sine pi x minus parentheses x to the third minus 4x dx. Either you must have the parentheses or you must distribute that negative. Don't just write down minus x to the third minus 4x because that's going to be wrong. It's not going to generate R area. Okay, so curiously, when I do this, I get 4 on my calculator. Okay, part B. Horizontal line y equals negative 2. Y equals negative 2. Splits R into 2 parts. Y equals negative 2. Alright. Says write but do not evaluate an integral expression to find the part of R that is below the horizontal line. So I'm looking for this. Okay. Um, well, I don't want to do right minus left. Um, that wouldn't be fun for me. So instead, I'm going to figure out when um, x to the third minus 4x equals negative 2. And I'm not going to be able to factor that cubic trinomial. So I'm going to use a calculator to find those points of intersection. And I find this one to be 0.539, 18887. And I find this one to be 1.675139. So what do I want to do here? I want to do top minus bottom between those points. So the integral of negative 2 minus x to the third minus 4x dx from 1.539188887 up to 1.6751309. And I think I was just supposed to write the integral. Yes, right, but do not evaluate the integral expression. I'm not going to do right minus left from here to here because A, I don't know that point yet, and B, this curve and this curve are the same, and so right minus left would be terribly, terribly difficult. Okay, so there's part B for number 4. Here's part A for number 4. Let's take a look at part C for number 4. The region R is the base of a solid. Cross-sections perpendicular to the x-axis are squares. Find the volume. Well, that's just going to be that top function, sine of pi x squared. No, it's not. It's going to be top minus bottom, x to the third minus 4x squared. Top minus bottom squared dx from 0 to 2. There's my integral, and when I do this on the calculator, I end up with 9.978 units cubed. There's number 3. Number 4. Number 4 says, 4D says the region R is the surface of a small pond. Ooh, hi pond. All the points in R at a distance x. So if I go over x, I get a distance across the pond. And while the depth of the water is given by h, find the volume of the water in the pond. Well, if we thought about a simpler shape, like this cube, we would know that the volume of this cube is length times width. That's the area of the top times the depth. So that's what I'm thinking about here. I'm thinking about integrating from 0 to 2 h of x, that depth function, times our area. And that area, like I'm not integrating area, I want what will give me the area. And what will give me the area is just top minus bottom, right? I'm adding up all these line segments, adding up top minus bottoms, top minus bottoms, top minus bottoms. Top minus bottom is going to give me this area times the depth dx. Okay, so then our integral would be 0 to 2 h of x times sine pi x minus x to the third minus 4x dx. And when I do this on the calculator, I get 8.370, and I don't have any units given to me, so I'm just going to go with units cubed. I wonder what those units are. Maybe they're miles. Probably not. Okay, what's next? Problem number 5. That last part, part D, that's sort of in line with the direction that the volume problems have been taken in more recent years. Okay. 5. 5 says, without a calculator, and yet we're given a scary picture. Scary picture. Oh no, funnel, Mr. Cooper. The radius of that funnel is given by 1 over 20, 3 plus h squared. Okay, on 0 to 10. So this must be 0 down here, and this must be 10 here. 0 to 10. Okay. Units R and H are inches. Find the average value of the radius. Okay, well, that's the average value of R dt from, I'm integrating here from 0 to 10. And they named R, so I don't have to. I can just, oh, this is without calculator. Son of a gun. Okay, well, I guess I gotta do some math then. So I'm gonna pull out that constant, and I'm gonna have 1 over 40 integral 0 to 10 of 3 plus h squared. Okay, so that's gonna be 1 over 40, 3h plus h to the third over 3 from 0 to 10, which is going to be 30 plus 1,000 divided by 3, or 1,090 times 1 over 40 over 40. So 109 over 4. That's what I would think. I got 109 over 60. What did I miss? Oh, average value. I'm such a goon. A of b minus a. 10. 10 times 20 is 200. And so that's going to change this number. 200, 200. And so I get 109 over 60. Oh, this 3 here. I am Mr. Going Too Fast. Okay. So I make a common denominator. And that gives me 90 plus 1,000 over 3 over 200, which is 1090 over 600, or 109 over 60. And those are inches. This is the average radius of this funnel from 0 to 10 inches. Okay, so there's part A. Part B, find the volume of the funnel. Well, I know in order to find volume of the funnel, I want to integrate area. So integrate pi radius squared dy from 0 to 10. I think I marked that right. Pi h, because radius is in terms of h. Okay, so that's going to give me 1 over 20, 3 plus h squared squared dh from 0 to 10. All right, that's a constant. I'm going to pull that out. Don't forget 20 squared is 400. So we have pi over 400. 3 plus h squared. Okay, dh. So that's pi over 400 integral 9 plus 6h squared plus h to the 4th dh. And the integral then, or the antiderivative would be, oh, and we want to go from 0 to 2. The integral would be 9h plus 2h to the 3rd plus h to the 5th over 5 from 0 to 10. And I'm not going to go any further than plugging the 10 in. Pi over 490 plus 2000 plus 1, 2, 3, 4. Isn't that? That's 10 to the 2nd, 10 to the 3rd, 10 to the 4th, 10 to the 5th, over 5. Because I don't really want to play the let's make a common denominator game. And so this is going to be 9, so I'm just going to stop here. Okay. Part C. The funnel contains liquid that is draining out of the bottom. Ooh, it sounds like a related rates problem now. What do we want to know? We know that when h equals 3, the surface, the radius, is decreasing by 1/5 inch per second. What is the rate of change in the height of the liquid, dh dt? Okay, well, let's see what we've got. We know radius is equal to 1 over 20, 3 plus h squared, or 20r equals 3 plus h squared. Now, if I take the derivative of both sides with respect to time, over here, I'm going to get 20 dr dt equals, the derivative of this is 0. The derivative of this is 2h times the derivative of the inside with respect to time. This is the thing I'm looking for, so I need to plug in values here and here. So 20 times 1 over 5 equals 2 times 3 times dh dt. This is going to be 4 divided by 6, or 2/3 equals dh dt. And don't forget units. These are inches per second. Okay, there we go. And the water is draining out at this rate. So water or fluid draining at, no, the height is, going down because fluid's coming out. So this must be a negative up here and a negative, and so we get a negative over here. So the height is changing by negative 2/3 or decreasing by 2/3 of an inch per second. Be careful with that. That comes to a point to be careless about that SIGN. Okay, there was problem number 5. You can see that's a little more thinky than we've been talking about recently. Problem number 6 says f and g are functions given by this, and yes, this is definitely with calculator. Part A, the sum of R and S areas. Okay, so the first thing I need to do is find that point of intersection between these two curves. They tell me this point of intersection is 2, 4, and this point of intersection is 0, 2. But I need to know where this is because my top and bottom flip at this x value. So when I graph and I do second calculate intersect, I find the x coordinate of this point to be 1.032839. So part A for me then is the function on top is the polynomial function minus that strange e to the x kind of function, and I'm going to do that from 0 to 1.0328319 plus the integral from 1.0328319 to 2 of f minus g. I want to flip those. When I integrate this on my calculator, I get an area of 2.004. Okay, that's part A. Part B. B says S is the region of a solid whose cross sections are perpendicular to the x-axis are squares. So I just want to do top minus bottom squared here. The top function is the strange e to the x thing, that's f, minus g, the bottom function, the polynomial. Top minus bottom squared. This gives me side length, this gives me side length squared. So I'm integrating area from, what was that x value? 1.0328319 out to 2. And when I integrate this with the calculator, I get the area of S, I get the volume is 1.283 meters cubed. Okay, part C. Part C says, let h be the vertical distance on the graph of f and g in the region S. Okay, so they're saying that this is h. Okay, what do we want to do with that? I don't know. They want us to find the rate at which h changes with respect to f, with respect to x when h equals 1.8. Huh. Well, so we know that h of x equals f of x minus g of x. And I want to know the rate of change in this. So I want dA dH dt, and that'll be equal to dF dt minus dG dt evaluated at 1.8. Oh, but wait. It's not with respect to time. There is no time here. It's with respect to x. That's much better, because I was just worried about plugging in this. So I need f prime at 1.8 minus g prime of 1.8, and I can find these using n deriv on each of them. I ended up with 2.116 minus 5.928, so I got that dH dt was equal to negative 3.812. Okie dokie. There is part C for number 6. Let's take a look at 7. 7. The rate at which rainwater flows into a drain pipe is given by RT. Okay, so R equals 20 sine t squared over 35. And that is cubic feet cubed per hour. Well, that's a change in volume with respect to time, so I'm going to just note that as dV dt. It's a rate, but it's dV dt as well. I mean, it's a specific rate. So what do we want here? In part A, look, D, 0 to 8, partially blocked, and the water drains out. Oh, so this is rate in, and D is rate out. And that's given by this other function, negative 0.04 t to the third plus 0.4 t squared. And the amount of water at time equal to 0 is 30 cubic feet. So it looks like we have a rate in, rate out problem, but it looks like we might also have a related rates problem. Let's see. Part A, how many cubic feet of rainwater flow into the pipe during the 8-hour interval from 0 to 8? Well, part A is simply the integral from 0 to 8 of r of t dt. I do that on my calculator, and I get 76.570 cubic feet. That's pretty straightforward. Part B, let's see what we've got here. Is the amount of water in the pipe increasing or decreasing at time t equals 3? So let's write an amount function. A of t minus a of 0 equals the integral from 0 to t of r rate in minus rate out dx. Okay, and we've got this initial amount. So a of t is going to be 30 plus the integral from 0 to t of r minus t dx. And we want to know if this amount is increasing or decreasing. And so last semester we said we could determine increasing or decreasing if we took the derivative of a function. So I want a prime. A prime, the derivative of 30 is 0, and the derivative of this integral with ftc1 is going to be r of t minus d of t. Okay, and we want to know if a prime of, what time did they want to ask us about? 3. A prime of 3 equals r of 3 minus d of 3. Okay, so I check these out on my calculator, and I end up with negative 0.3136 cubic feet per hour, and so amount is decreasing at t equals 3. And you could say, as if this weren't enough reason, you could say because amount draining, or better yet, d of 3 is greater than r of 3. No, just that. Okay, so there's part B. Part C says, on the interval 0 to 8, is the amount of water in the pipe at a minimum? Oh, at what time? Okay, so again, we want to know when amount is a minimum, so I want to take the derivative of amount. There it is. And I want to set the derivative equal to 0. So if I set this equal to 0, a prime equals 0, that's going to give me 0 equals r minus d, where d equals r. So I want to find those points of intersection, and when I graphed, I only found one on 0 to 8, and that was located at 3.272. If I check a prime on either side of this, I get a minus over here and a plus over here. So I know that this is my minimum. From this amount, the amount is decreasing until this time, and after this time, the amount is increasing. And so t equals 3.272. And did they want absolute minimum? No, they just said a minimum. So I don't have to do anything other than say the amount of water is a minimum at t equals 3.272 because to the left of t equals 3.272, a prime is less than 0, and to the right of t equals 3.272, a prime is greater than 0. So there's part C. And what about part D? The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, do we know the amount at 8 yet? Did we figure that out? How many? Yes. So we figured out, no, that was how much flowed in. All right. I got some thinking here. The pipe can hold 50, and for t bigger than 8, water continues to flow into the pipe at the given rates until the pipe overflows. Right, but do not evaluate an integral involving one or more integrals when gives the time w when the pipes begin to overflow. Okay, so these are times, these are our hours, and so I have integrating time here. And so I think, okay, I could do this problem a couple of ways. From 8 to w of r minus d, but that doesn't take into account how much is already in there at time equal to 8, so we would not need to add a of 8 to this. Right, because we're thinking about doing integral from 0 to w of r minus d dt equals 50. I guess we could just do that. Because they both flow in at the same amount. Yes. Oh, but in this case, remember, we need to have the initial amount. So this would be plus the initial amount to make that 50. Okay, so either one of these would suffice. Do I have to find a of 8? I probably would feel like I'd want to find a of 8. Yeah. Okay. So with this one, write but do not solve. Okay, write but do not solve. Okay, I guess I'm done with part 2. I was just reading my notes on part C that had only the one min. Well, guess what? They did a candidates test there. Can't believe it. They said they wanted to know the amount at 0, they wanted to know the amount at 3.272, and they wanted to know the amount at 8. And I guess this would be useful in this. And luckily we had built an amount function. This was given to us. And so here it's just going to be the integral from 0 to 3.272 r minus d dt plus the original amount. And this one is the integral from 0 to 8 of R minus D plus the original amount. Yeah, so full candidates test. That seems like a cheap shot, but maybe. I don't know, there's only one min. I guess, that stuff I said about the endpoints on maxes, you'd have to write that out as sentences or do the full candidates test. Okay, moving on to 8. Problem number 8 says a tank with a height of 10 feet with an area, trapezoidal cross section of the tank with a height given by h. Height given by h. And the area is given by a of t measured in square feet. The function a is continuous and decreases as h increases. So the higher up we go, the smaller this area is. Okay. Selected values are given. Use a left Riemann sum with 3 subintervals to find the volume of the tank. Okay, so I know that when I integrate area, I get volume. So I'm integrating this area function, which means, and they said a left Riemann sum, yes, so 2 minus 0 times the first area plus 5 minus 2 times the second area plus 10 minus 5 times the third area. Okay, I'm kind of tempted just to leave it there. This is with calculator. Oh, indicate units of measure. These would be cubic feet, because I did feet times feet squared. So this number of cubic feet. If you did compute this, you should get 176.3 cubic feet. There's part A. Okay, part B for number 8 says, does the approximation, is it an overestimate or underestimate for the actual volume of the tank? Well, we learned in the stem of the problem that A decreases as H increases. So here's our H, here's our A. As H increases, A decreases. So when we do a left Riemann sum, notice we're getting an overestimate. If we do this kind of decreasing, and we do a left Riemann sum, we still get overestimate. And so I'm going to say our estimate is an overestimate because A of t is decreasing. And n is always an overestimate for a decreasing function. Okay. Now what? Part C. The area in square feet of the horizontal cross section at height A, h, is modeled by this function. F of h equals 50.3 e to the point 2h plus h. Based on this model, find the volume of the tank. The area is modeled by this. This is the area function. Well, if this is area, I know that I'm supposed to integrate area to get volume. So I'm just going to integrate f of h d, dh and integrate from 0 to the height is 10. And when I do this on my calculator, I get 101.325 cubic feet. Okay, finally part D, that was part C. Part D for number 8 says, water is pumped into the tank. When the height is 5, the height is increasing at 0.26 feet per minute. Okay. Use the model in part C. Use the model f of h equals 50.3 e to the 0.2 h plus h. The area, and this is area as a function of height. So this is feet squared. Okay. Use the area model from part C to find the rate at which the volume of the water is changing at h equals 5. Okay, so I remember that dv dt equals dv dh times dh dt. Now, what about these things? Well, dv dh dv dh oh, so this is cubic feet per foot times feet per second, and so we end up with cubic feet per second. That's why this dv dh times dh dt is going to work. Now, dh dt was given to me, but what about dv dh? dv dh, the change in volume with respect to height. The change in volume with respect to height. Well, let's think about this. Remember how in part C I said if I integrate this, I'm going to get volume? Well, let's take the derivative of this equation. Okay, so dh, I guess I want some different letters there. X, d, dh. So over here, I'll have dv dh. And over here, the derivative with respect to h of this integral from 0 to h is just going to be f of h. So dv dh is f of h. So what I need to do in this problem is evaluate f of h times dh dt. Now, this is when h equals 5, so I want f of 5 times 0.26. F of 5 times 0.26, and I get 1.6944 cubic feet. And I'm sorry, these were minutes, not seconds. All right, yeah, that's some thinking going on there. That's some thinking. Not a lot of kids in America got that one correct in 2017. I'll tell you that. But you know, it's that idea of understanding the underlying conceptual nature of what's going on. I'm looking for dv dt. They've given me dh dt. What would I have to here? Let's work it backwards. What would I have to multiply this by to turn it into this? Well, I'm going to have to get rid of a dh, so that's going to be on the bottom. And I'm going to have to introduce a dv, so that has to be on the top. And then I have to go about finding these. dh dt was given to me. But dV/dH, I had to think about. That's the change in volume with respect to height, and we determined that that was that f of h function. Okay, 3 problems left. Problem number 9. Oh, this looks like a textbook problem. Problem number 9 says, use the trapezoid rule to estimate the volume of the pond. Well, we know that volume is going to be the area times the depth. And we're told that the average depth is 20 feet. So I want 20 times the cross-sectional area of this pond. Well, the subinterval width is 200 feet. So, and I'm supposed to use trapezoids, so 1/2, 200. And then, since the subinterval widths are all the same, I can do my shortcut, finally, 520 plus 2 times 800 plus 2 times 1000 plus 2 times 1140 plus 2 times 1160 plus 2 times 1110 plus 2 times 860 plus a 0. All right, that's going to then be the volume. And if I compute this, I get 26,360,000 cubic feet. Okay, lots of cubic feet in that lake, pond. All right, next, part B says you start the season with 1 fish per 1,000 cubic feet. Okay, so 26,360 fish because I divided by 1,000. Okay, that's at the start of the season, and you intend to have at least 25% of this number left over at the end of the season. Which means, I guess, if we want 25% left over, 0.25 times 26,360, that's going to be how many left over. We're saving 25%, which means we've used or caught, fisher people have caught 75%. And we're told that each of those people needs a license, and they want to know how many licenses if the maximum number of fish that you can catch is 20. So let's divide this number by 20. So I've got 75% of the fish, the original fish, were caught, and we're going to divide that by 20 to find out how many licenses we could have, and that's going to be divided by 20 caught per person, and so I end up with 988.5 licenses or people. Okay, there's part B. We're done with number 9. Number 10. 10 says functions. Oh, we did this one. Wasn't this one? Oh, no, we didn't. We did one like this one. This is like problem number 2 from the packet, but it is not problem number 2 with the packet. Okay, so we should be able to go through this expeditiously. We've got 2 functions, a square root function, square root of x, and then we've got 6 minus x equals g, and f equals square root of x. And they meet somewhere at 4, 2, we're told. Okay, this is without calculator. Find the area of region R. You know, again, I wanted to right minus left. You're welcome to do this as the integral from 0 to 4 of square root of x dx plus the integral from 4 to 6 of 6 minus x dx to find that area, but I'm going to do this as the integral from 0 to 2, because I'm going to go this way, and this is 6 minus y minus solve this for x, and I get y squared dy. Um, so I've got 6y minus y squared over 2 minus y to the third over 3 from 0 to 2. 12 minus 2 minus 8 thirds gives me 10 minus 8 thirds. 30 minus 8 is 22 thirds. And that's an area, so that's units squared. Okay, part B. Part B says the region R is the base of a solid for each y. Solid perpendicular is a rectangle. So now we're building rectangles where right minus left is the base of that rectangle. And we're told that the height is always twice the base. Okay, the height is always twice the base. Well, I know the base is going to be right minus left. And so 2y times 6 minus y minus y squared dy from 0 to 2. Do I have to write and solve, or just write? Write, but do not evaluate. Done. Okay, well, I'm really glad I did right minus left for the last problem. It saved me a lot of time in part B. Okay, part C. Part C says there's a point P on the graph of F for which the line tangent to the graph of F is perpendicular to the graph of G. Huh, okay. That's interesting. So, and do we know any more? The point F. Okay, so f of x equals square root of x. F prime, because, right, I need more the right tangent line. I need a slope, so I get 1/2 x to the minus 1/2, or 1 over 2 root x. Now, any slope, this tangent line, wait a second, it says that this tangent line, tangent to f, is perpendicular to g. So g, the slope of g, is given as -1. And we remember that the slopes of perpendicular lines are opposite reciprocals, right? So if you had 2/3, then the perpendicular line would be -3/2. So if the slope of this line is -1 and it's perpendicular to that one, the slope over here should be 1. 2 root x, so 2 root x equals 1, root x equals 1/2. Don't forget to square both sides, not take the square root of both sides, and you get x equals 1/4. And what was it looking for? It's looking for the coordinates, x and y value. So I have to plug this 1/4 back in here. Square root of 1/4 is 1/2. So P is located at 1/4, 1/2. Great. And our last problem, problem number 11, another textbook problem. This one says the volume of a swimming pool is given by the integral from 0 to 50 of 30 times h of x. And h is the depth. Okay, I guess we have a rectangular cross-section. So the depth is changing, but the shape of the top of the pool is not undulating along like the pond in problem number 9. So what do we have here? We just kind of pull out that integral, 0 to 50 of h dx, and They say estimate the volume of the water using a trapezoid sum with n equal to 10. Oh, okay. Well, I pulled that out. I'm going to use my trapezoid rule on this. I see that the subinterval width is always the same. It's always 5. And so I think I can write 30, 1/2 subinterval width, and then our shortcut, 1 of the first height, plus 2 of 8.2, plus 2 of 9.1, plus 2 of 9.9, plus 2 of 10.5, plus 2 of 11.0, plus 2 of 11.5, plus 2 of 11.9, plus 2 of 12.3, plus 2 of 12.7, plus 1 times 13. Okay, there's our trapezoid sum. And I'm going with calculator on this one, and I end up with 15990 cubic feet. All right, that's the last of volumes. I hope this was helpful, and don't forget to ask me any questions. Have a great day.